Hello everyone, I Dr. Sanjay Upreti welcome you to the channel Electrical Science by Dr. Sanjay Upreti. In today's video, I am going to discuss a problem of AC circuit uh, where you are asked to find out the impedance, resistance, inductance and the power factor. So in this question, it is given that the 10 ampere inductor coil is connected to some source of 250 volt and it draws the current 10 ampere, and then 1000 watt it consumes the power, it dissipates the power of the 1000 watt. So you have to find out the impedance, resistance, inductance and the power factor of the coil. So that question was asked in the final paper of a IP University examinations. Uh, so let us find out this how to solve this one. So let me first draw the circuit for you. So if you draw this circuit here, so you can find here this coil is connected to 250 volt and ammeter and the wattmeter are connected. Wattmeter and the ammeter are connected. So reading of the ammeter is a 10 ampere and reading of the wattmeter is a 1000 watt. So first let me find out the value of the impedance, right? This is the impedance to impedance. So impedance can be calculated by the Z can be calculated by the V divided by I. Like in a DC circuit, it is equal to the R. Resistance is the ratio of the voltage and current, but in a AC circuit it becomes the impedance. So this for to find this impedance, the value of the voltage is given here as the 250 volt and the current is given here as the 10 ampere. So it will be equal to the 25 ohm. So impedance of this circuit is 25 ohm. Second part is the resistance. So resistance is also can be calculated by by this knowledge of that in a AC circuit the power is only consumed by only the resistor part, right? Rest of the inductor basically does not consume any net power. It stores the power in one cycle and releases the power in a second another cycle. So net power here is a zero. So only power will be consumed by the resistive part. So it can be, the power can be given by, power in the circuit can be given by the I square into R. Voltage I square multiplied by the resistance, or it is given as a 1000 watt. So R can be calculated. I is given as a 10 square into R is equal to 1000. So it will give you the R will be equal to the 1000 divided by square of the 10 is 100. So it is equal to the 10 of ohm. So the coil is having a resistance 10 ohm. 10 ohm, right? So third part, the resistance, we have found the resistance. The third part is here, it is the inductance. So inductance can be find out by the impedance triangle. So the impedance in a RL circuit, it is can be given by the Z is equal to square root of the R square plus XL square. R square plus XL square. So it implies that that is 25 is equal to root of R. We have calculated the value of the R here. So it is equal to the 10 square plus XL square. So simplifying this one, it will give you the XL square. XL square is equal to 25 square minus 10 square. So 625 square is the that is 625. If you square the 25, then the value of the 25 square is equal to 625 minus 100, or it is equal to the 20. Sorry, this one is equal to the 525. 525, right? So value of the XL is equal to root of square root of the 525, or that will be that if you take the square root, So that will be coming as a 22.91 ohm. So it is the value of the XL, or XL is also, it is also called the inductive reactance. So to find the inductance, so you can XL can be given as a 2 into pi into F into L. Here is the F is the frequency, and frequency here is given is the as a 50 hertz. So with this one we know the XL value of the XL, we know the you can calculate the value of the L. So L can be given by here as a XL divided by 2 pi into F. So value of the XL is given coming as a 22.91 divided by 2 multiplied by value of the pi is the 3.14 and multiplied by 50, that is 50 is the frequency. So if you simplify this one, it will become 22.91 divided by 314 divided by 314, or if you divide this one by 314, so it will give you 0.0729. So value of the inductance here, inductance value is the 0.0729 Henry. So it can be also can be written here as a L can be written here as a 72.9 millihenry. So this is the value of the inductance is 72 by 72.9 millihenry, and the value of the current here is the value of the resistance is 10 ohm, and value of the inductance is the. So last part is the power factor. So power factor in a inductive in a RL circuit can be given by the PF is equal to R divided by the impedance, resistance divided by the impedance. So value of the R is given here as 10. We have calculated. Value of the Z is calculated 25. So if you divide, so that is the 0.4. So power factor will value of the power factor is the 0.4. So I hope this you would like the all the explanation of this question, and if you like, then hit the like button and subscribe to the channel. Thank you very much.